What is index and indices? Do we really have any need for laws of indices? How can we apply those laws of indices in calculation? Today, we are going to start with normal grade series. Normal grade series, we treat topics taught to grade 10, 11, and 12 in most high schools. Today, we are going to take the topic indices and logarithm. Indices and logarithm. As we asked the question from the beginning, what is index and what is indices? If a number is written as 2 raised to the power 3 times 2 raised to the power 4, one would ask, is it right for us to say 2 times 2? If 2 times 2 is what we are going to say according to what we have been doing before in ordinary operation. The operation here is multiplication. 2 times 2 is 4. Okay, is 3 times 4, which is 12. Will the answer to this question be 4 raised to the power 12? The answer is no. So that is not going to be correct. We now see that because indices is not following the normal calculation, like this has disobeyed this multiplication here, we are going to have its own law. So we have laws of indices. Laws of indices number 1. Laws of indices number 1 is saying that when we have x raised to the power a times x raised to the power b, the answer will be obtained when you have x raised to the power a plus b. Okay, remember that x, a, and b here are numbers, but we use the letters so that we make sure that we generalize whatever the number that is going to take the position, we take it later. Examples. Example 1. Number 1. Let us make this example A. In example A, to solve this question here, 2 raised to the power 3 times 2 raised to the power 4. Someone that knows mathematics but doesn't know the laws of indices may decide to tell us that this is what we are going to do would be 2 times 2 times 2, which represents the first number in the brackets, then times, which is the multiplication sign we have here, 2 times 2 times 2 times 2 into 4 places, which represents the second number here. Then the person may now flip all of them to have 2 times 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6, 7. Making it that we are going to have 2 raised to the power 7 as our answer. Okay, but what if the index here is very big? Have you thought about something like 2 raised to the power 20 times 2 raised to the power 99? Which space and time will help us to do that. Therefore, the law of indices will make it better for us. And so we are going to work this as 2 raised to the power 3 times 2 raised to the power 4. We will not expand them. The law of indices permits us to say that we are going to pick one base. The base here is 2. So when we pick one base, just add the indices. The index of this is 3 and index of this is 4. Therefore, we are going to have 2 raised to the power 7 as we got before. Can you see that this is shorter? Then, that is what the laws of indices is talking about. Here we have simplified the calculation. Take example number 2. Example number 2, if we have That is example B. Assuming we have 3 raised to power 2 times 3 raised to power 3. The law permits us also to say that this is equal to 3, just pick one base, not 2. 3 raised to power 2 plus 3. 2 plus 3 is 5. And so, we are going to have it as 3 raised to power 5 as the last answer. It is allowed that when the number is up to raised to power 5, we can leave it like that. We can also expand when it is smaller than that. In whichever way, we can always multiply out if it is small. For instance, 3 raised to power 5 should be 3 times 3 times 3 times 3 into 5 places. Okay, what if the bases are not the same? Let's take a look here where we have C. Assuming the question given to us is to simplify 5 raised to power 2 times 125. 5 raised to power 2 times 125. We cannot pick the same base here because they don't have the same base. Our first job then is to make sure that they have the same base. And so we have 5 raised to power 2 times 5 raised to power 3. Is it confusing? I think it shouldn't be, because we can always divide this 1, 2, 5. Use the prime number that is the smallest number to divide it. And we have 5 divided to give you 25, 5 divided to give you 5, 5 divided to give you 1. And so 5 times 5 times 5 will give you 1, 2, 5. Again, we have it at 5 raised to power 3. Now they have been expressed at the same base. And so we can easily pick one base now, 5 raised to power 2 plus 3. And eventually we're going to have 5 raised to power 5 as our last answer. This is the first law of indices. What of the second one? Take us the second one, law number 2. The second law of indices is not taking charge of times again. What of when we have x raised to power a and division is between them, x raised to power b? The law is asking us to simply pick one base and say x raised to power a minus b. Examples. Example A. If we are given 4 raised to power 3 divided by 4. If we write 4 like this, note that the 4 alone is simply 4 raised to power 1. We can reduce this to base 2, but since they have same base 4 here, let us continue with that. This is going to be written as 4 raised to power 1, and then we pick one base 4 raised to power 3 minus 1. 3 minus 1 will give us 4 raised to power 2. Because the index of this last answer is very small, we can easily say 4 times 4, and that is 16. Remember, they have the choices of either leaving the answer in this form or in this form. And we are expected to know that they are the same. Example number 2. If we have example B as 3 raised to power 4 divided by 81, for instance. You can see that in this one, they don't have the same base. So what do? The same thing we did before. We try to make sure that 81 as a number, we have the same base that we have here. And so we are going to divide 81, 3 divide 81 to give you 27. This is very fast, isn't it? Let us just say 3 divide 8 will give you 2. What is the remainder? The remainder is 2. We'll put that 2, it is 21. 3 divide 21 will give you 7. And so that is 27. We can use 3 again. 3 divide 2 cannot just go. 3 divide 27 will give you 9. 3 divided 9 will give you 3. And 3 divided 3 will give you 1. And so, the number 81 will be written as 3 raised to power 4 divided by 3 raised to power 4. And so what are we going to do? Pick one base. Do not divide them. Just pick one base. 3 raised to power 4 minus 4. And so 3 raised to power 4 minus 4 will give us what? Will give us 0. So we have it as 3 raised to power 0. It's either we leave it as 3 raised to power 0 as the last answer, or we recall that 3 raised to power 0 is 1. Every number raised to power 0 is 1. Then let's go to law number 3. Law number 3 takes care of when the index is a fraction. The law number 3 is saying that x raised to power 1 over a will give you root a of x. Root a of x. That means if you take examples, example A for instance, and we have a number like 25 raised to power 1 over 2. How can we raise 25 to power 1 over 2? How can we take 25 to power 1 over 2? We are going to take exactly what this law says that we should take. That's the step we are going to take. The step is that x is 25, 1 here is equal to 1 here, we have here, and a is 2. Meaning that we are going to say that this will give us something as square root. 20 square root 2 is here, but it's not often written. So it's going to be square root of 25. Square root of 25. Do we know what the square root of 25? Square root of 25 is going to be 5. Assuming you don't know why, get that 25, square root of 25, by dividing by the smallest prime number. Here, the smallest prime number is 5. 5 divided 25 will give you 5. 5 divided 5 will give you 1. Because 2 is here, any number that appears twice, you pick it as 1. And so 5 has appeared twice here. Square root of 25 is 5. That's why it is 5. Assuming we have a question, example 2. In example 2 that gives us something like 81 raised to power 1 over 4. 81 raised to power 1 over 4. We're also going to take the same approach, where a in this case is 4. We are going to take it that this is the something as 4th root of 81. 4th root of 81. We also going to do the same thing. How can we use a prime number and continue to divide 81 and continue to divide 81 and we get 4 of it? And what is that number? We are going to divide and find that number. 81, 2 cannot divide without remainder, so we are using 3. 3 divided will give us 27. 3 divided will give us 9. 3 divided will give us 3. And 3 will give us 1. Remember, this is the root. And any number that appears up to the number of the roots, you pick it as 1. And so 3 has appeared 4 times here. We are talking about the 4th root. 3 has appeared 4 times, so we are going to pick 3 as 1. Therefore, 81 raised to power 1 over 4 will give us as the answer 3. It is 3. That's about the third law. Now, fourth law. Fourth law is an improvement from the third law. The law number 4. The law number 4 is saying, assuming we have x raised to power b over a. In this case, 1 is no longer what is up here. It is b, suggesting that it could be another number apart from 1. And so, the law says we should take it the way we took the other one, that is going to be a root of x. But we are going to say all raised to power b, the numerator. Always remember this. Root of the denominator raised to power numerator. Here we don't need to say raised to power 1. You understand? Because any number raised to power 1 is that number. 4 raised to power 1 is 4. 3 raised to power 1 is 3. So we don't need that. Here we need to say it because it will make a difference. An example. Repeating what we have used as an example number 1 here. Assume we have 25 raised to power 3 over 2. This time around, it's no longer 1 over 2, but 3 over 2. We follow the law. Remember, we must follow this law number 4 because we can see that b is something else. That b is 3. And so we are going to take it to be square root again of 25 all raised to power numerator. And the numerator here is 3. All raised to power 3. The same thing we've done in this example. We find the square root of 25. And from what we have found so far, the square root of 25 is 5. That 5 raised to power 3. 5 raised to power 3 is going to give us the same thing as 5 times 5 times 5. Please avoid that mistake of thinking that this is 5 times 350. No, because the 5 is only telling you multiply myself into 3 places. That is what it is saying here. 3 places. 1, 2, 3. 5 times 5, 25. 25 times 5 will give us 1, 2, 5. We can say therefore that 25 raised to power 3 over 4 will give us 3 over 2 will give us 125. I hope you understand. This is the third and fourth law. Alright. Law number 5. Law number 5 is interested in a number raised to power 0. Because so far we have talked about whole numbers, raised to power whole numbers. We have also talked about raised to power fraction. But what of when it is raised to power 0? The law is saying that x raised to power 0 is 1. Is 1. What does it mean? It means that if we take example A, that x raised to power 0 is 1, meaning 2 raised to power 0 is equal to 1. 5 raised to power 0 is equal to 1. 205 raised to power 0 is 1. How do we take it to be? We can see a proof to that. Let us find out that is true. How can it be that every number raised to power 0 is 1? Let's see a proof here. Assuming we use law number 2 to prove it. Law number 2. Assuming we take 2 raised to power 3 divided by 2 raised to power 3. Let us use this and find out whether it is true. That any number raised to power 3 is going to, raised to power 3 is going to give us 1. Take a look. This means from our simple calculation that 3 raised to power 2 raised to power 2, 2 raised to power 3 is going to be divided by 2 raised to power 3. That means this is being divided by this number. Let us expand it, but that is what is going to give us the surest answer from what we know from elementary calculation. So we are going to take it to be, okay, this is 2 times 2 times 2 into 3 places, representing the numerator, and then 2 times 2 times 2. We can cancel out. 2 divide itself 1, divide itself 1, divide itself 1, divide itself 1. 2 again 1, 2 here 1. We cannot divide again. 1 times 1 times 1 will give us 1. That's okay? Then 1 times 1 times 1 will give us 1. And 1 over 1 is 1. So we view this approach now and see that in our simple calculation we know from elementary school that this is going to give us 1. Let us now apply the law according to law number 2. The law number 2 that says x raised to power a divided by x raised to power b is equal to x raised to power a minus b. Let's apply it here and say, or this is going to be 2 raised to power 3 divided by 2 raised to power 3 will give us pick 1, 2. That means 2 raised to power 3 minus 3. And so we are now going to have 3 minus 3 is 0. If it's 0, then 2 raised to power 0 is what 14 again. Okay. So if this calculation we know very well before gave us 1, we are now sure that 2 raised to power 0 will give us 1. So this is the proof. And we won't have any doubts about it again. Okay. This is about law number 4, 5. I think this is one of the easiest of it, because even if it's the letter, m raised to the power 0 is 1, p raised to the power 0 is 1. Any number raised to the power 0, mathematics is saying here is supposed to give us 1. Law number 6. Law number 6 comes with a different approach, a different solution to calculation. Assuming we have a number that is raised to the power a negative number, what do we do about it? Assuming we have x raised to the power minus a, the law is saying that x raised to the power a will give you, first of all, make sure you change this negative sign to become positive before you know what to do. And so, what do? It's as if we are going to say 1 over x. Immediately you have put 1 on top. Now, and make your dividing line, let the negative sign go. So we are going to have 1 over x raised to the power a. Remember, draw your dividing line and allow the negative sign to go. Assuming this is not logical to you, doesn't make sense. How can I draw the dividing line? Allow the negative sign go. Where has this negative sign gone to? Take this approach as what can also serve as a logical approach to it. Do it this way. Consider x to be a whole number. Assuming we have x to the power a is a whole number. Every whole number can be written as 1. That means every whole number can be written over 1. That means we can write it over 1. Take it that when you write that over 1, that you can just turn it. If you turn it, mathematics is saying that it will change to become positive instantly. So the sign negative here will vanish. Whichever one that gives you the better understanding, you follow it up. For example, if we have example 1 as 5 raised to the power minus 2. The law is saying that you have to clear this negative sign first. And so that is going to give us, put 1 on top and let the negative sign go. 1, 5 raised to the power 2. No negative sign again. And so when you come to this point, you are going to say 1 over 5 times 5. So that is what 5 raised to the power 2 is. Please, 5 raised to the power 2 is not 10. It's not 5 times 2. It's 5 times 5. The base is being raised to the number of the index we have. And so what we are going to have as a final answer is going to be 1 over 25. We can conclude here that 5 raised to the power minus 2 is equal to 1 over 25. Very interesting, isn't it? Alright, but what about when we have example number 2 as this, as 3 over 4 all raised to power minus 2. How will you write it? Okay, we can use another index. Let us see if we use raised to power minus 3. Let us use another index. Assuming we have this. What are we going to take it to be? Are we going to say 1 over 3 over 4? That may be a little confusion to some people that are just starting calculation. And so it is better we do take it the way we talked about it from this position. Let us count the number. Let us find the reciprocal of the fraction. Once you find the reciprocal of the fraction, negative sign goes. And so we are going to take it to be 4 over 3 all raised to power 3. The minus has now gone because we have found the reciprocal, have turned upside down the fraction we have here. And so what we're now going to have is 4 raised to power 3 all over 3 raised to power 3, which we have 4 raised to power 3 over 3 raised to power 3. Or we have it as 61 over 27, leaving it as improper fraction. That becomes the answer, which we can as well change to a mixed number. So that is about the law number 6. Then the last one today is going to be law number 7. Law number 7. Law number 7 is saying what of when we have index and there is another index at the back of it. That is giving us to say x raised to power a or raised to power b. How do we handle such a question? Then we add the losses, multiply it out, take it to be x raised to power a times b, meaning x raised to power ab. A times b is ab. If we have example as 3 raised to power 2 or raised to power 4, the law is saying don't worry yourself. Just multiply the indices, the one that is inside and the one that is outside the brackets. And so the work is going to be 3 raised to power 2 times 4. 3 times 4, that means 3 raised to power 8 will become the correct answer to this question. I hope you understand. That's all right. So it's also very, very easy. Let us see a situation where one of them may be, or another side, one of them may have fraction. In example number 2. In example number 2, take a situation where we have 2 raised to power 1 over 2 or raised to power minus 4. 2 raised to power 1 over 2 or raised to power minus 4. In a way, we are going to multiply the two indices. And so, in our solution, we are going to tell them that 2 raised to power 1 over 2 or raised to power minus 4 will give us 2 raised to power 1 over 2 times minus 4 over 1. Please make sure we do not treat any of the indices here as if they have the same line with the base. It's a common mistake that we see candidates making the exam. And so what we are going to have is 1 over 2 times minus 4 over 1. Already, plus times minus will give us minus. So we must get to a negative number. And so 2 can divide. 2 divide will give us 2. Nothing again to divide. 1 times 2 is giving us 2. So minus 2 will be the outcome of that calculation. So we are going to have 2 raised to the power minus 2. The whole of the indices here has given us minus 2. And so we have it as 2 raised to the power minus 2. Now we remember that we have to apply what is given to us there in the formal law. So we must do it this way. We must say, okay, 1 over 2 raised to the power 2. Writing 1 on top, I'll let the negative sign going away. Then it's going to be 1 over 4 as our last answer. Therefore, we can tell them that 2 raised to the power 1 over 2 or raised to the power minus 4 will result to 1 over 4 as the last answer. These are laws of indices from number 1 to number 7. We still have more of them, up to 8, 9, 10, up to 15, depending on how far one would like to go. However, because I am very conscious of the syllabus, that this is normal grade series, where we are targeting students that are in grade school. We can stop at this number 7. Remember, they are 1 x raised to the power a times x to the power b equal to x to the power a plus b. 2 x to the power a divided by x to the power b equal to x to the power a minus b. Number 3, x raised to the power a 1 over a equal to a root of x. Number 4, x raised to the power b over a equal to a root of x all raised to the power b. And number 5, x raised to the power 0 being equal to 1. Number 6, x raised to the power minus a being equal to 1 over x raised to the power a. And finally, number 7 here, x raised to power a bracket b being equal to x raised to the power a b. These 7 laws of indices are used in solving 2 types of questions in most exams at this level. 1, simplification of calculations involving indices. 2, solving equations involving indices. My dear viewer, we are going to come to an end of this particular class today. Remember, anything that you don't understand in this section, please comment on my page, like and share. Later, I'm going to be able to address any problem you are getting from this, whether it's from the questions I've already solved here or from any question that is related to it. Thank you very much.